Okay, so um, uh, the linear momentum. So now we write those terms which are for E and B. So those terms are now uh, AK lambda, AK lambda, e to the power iota k dot r minus kct plus minus a k lambda dagger uh, e to the power minus iota k dot r minus kct. This is the term for E. Then we have a term for then the other factor for B, that is a k prime lambda prime e to the power iota k prime dot r minus k prime ct minus a k prime lambda prime dagger e to the power minus iota k prime dot r minus k prime ct और ये ब्रैकेट ठीक है. Now we can use the delta function or Green's function to calculate the integrals. So the integral, so using the Green's function for for the solution for the for solving rather for solving for solving integrals, i.e. कैसे जैसे इंटीग्रल d3r e to the power iota k dot r uh, into e to the power minus iota k prime dot r, yeah, and that would be equals to the total volume and the delta function k prime. So इसका मतलब since these are the basis function, the exponential parts, these are the basis functions, so the integral would sum over to the total volume for k is equals to k prime. So if k is equals to k prime, if k is equals to k prime, then this delta function would be equals to 1 and the total integral would be in fact v. So these two factors would cancel out, and delta k is equals to delta k prime would be equals to 1, and the total volume sum over the whole space that would be equals to v. And similarly there are other terms जो जिनको हम solve कर सकते हैं, and so on etc. Yeah. uh, those that survive, जो सिर्फ जो रह जाएंगे due to the factors which are basically cross triple products, they would be equals to plus k. Yeah. So and uh, and बल्कि rather most of the terms will cancel out, and those which survive are due to this factor epsilon k lambda cross k epsilon k lambda, which is equals to plus k. And so that the linear momentum g would be equals to summation over k k k lambda half k lambda half times h bar ck times a k lambda a k lambda dagger plus a k lambda dagger and a k lambda, एंड दिस इज इक्वल्स टू, अगर हम प्रॉपर्टी लगा लें कम्यूटेटर वाली, तो दैट वुड बी एच सी के डैगर, सो एच सी के बार ए के लैम्डा dagger and a k lambda. Okay? And this is equals to g linear momentum, which is summation over k comma lambda and h bar ck times the number operator nk lambda. And this suggests that a k lambda जो कि बुनियादी तौर पर एक फोटोन क्रिएट करता है, will have a linear momentum of h bar ck. So, which suggest that a k lambda dagger creates a photon with with linear momentum of h bar ck. Yeah. Uh, and there is also a 0 point energy term जो कि हमने यहाँ पर नहीं लिखी, s k and minus k term cancel out. So because of this factor, because k and minus k terms they are cancelling, so that 0 point energy term would also cancel out. So since k and minus k terms cancel cancel out, therefore therefore there is no 0 point term. Yeah. Now we can also consider or calculate the angular momentum of the field. And to calculate angular momentum of the field, we need to use again a property from calculus, which is basically R cross or a vector triple product. That is the curl of in fact E cross B. Yeah, sorry, the cross product with E cross B. That is the cross product cross product of the position vector R with E cross B. That would represent the angular momentum. Yeah. So now considering the angular momentum, and for angular momentum of the field, angular momentum of the field, and to consider the angular momentum, let's represent this angular momentum with J vector, which is equals to 1 upon 4 pi C, an integral over the 3 space, then the cross product of R with E cross P. That is basically the uh, when you talk about angular momentum as L is equals to R cross mv, yeah, and mv is the linear momentum. So linear momentum which we have already taken, and so that is R cross mv, and that is basically the angular momentum. Uh, and obviously it would include it would contain the similar calculation, and using the identities from differential calculus, the result which we obtain would be so a similar uh, calculations can be performed, yeah, and using uh, some usual differential calculus identities, one can obtain following result. And what is that result? That is J is equals to 1 upon 4 pi C, the same factor we had. Then we have an integral d3r over the 3 space. Then the factors because of those identities. So we have Ej of r cross delta Aj plus E cross A. Yeah. So this is basically the first term represents the orbital part, and the second term is in fact the intrinsic angular momentum of the photon. So this part represents the orbital part, and this second term is the intrinsic intrinsic angular momentum of photons. Yeah. So और हम क्योंकि रेडिएशन गेज इस्तेमाल करें, अब हमने शुरू में कहा था कि वी आर यूजिंग सम सॉर्ट ऑफ अ गेज वेयर डेल डॉट ई इज इक्वल्स टू जीरो. सो द सरफेस टर्म जो होगी इसके अंदर सरफेस, जब आपके क्रॉस प्रोडक्ट सॉल्व करेंगे और आइडेंटिटीज का इस्तेमाल करेंगे, एक सरफेस टर्म भी आएगी. सरफेस टर्म का मतलब है दैट इज द टर्म विच इज डाइवर्जेंस ऑफ द इलेक्ट्रिक फील्ड. एंड उसकी वजह से दैट सरफेस टर्म जो है वो सिफर क्यों हो जाएगी, बिकॉज डेल डॉट ई सिफर है. या सो where a surface term goes to zero due to del dot. This is the surface term, del dot E, divergence of the electric field, and divergence of electric field is zero. Yeah, and so because we are talking about a free field. Yeah, so if we are talking about free field, heading देखें free field है, so इसका मतलब है कि the surface term would be zero. So why? Because when you solve triple product this triple product इधर गई this triple product, this one. So you would, in addition to these two terms, जो ये और ये टर्म आ रही हैं आपके पास, ये टर्म और ये टर्म आ रही हैं, एक surface term भी आएगी which is in fact the divergence of the electric field, and that divergence of the electric field is zero. Why? Because we are talking about the free field. Yeah? Okay, so this is the two terms. The orbital part जो है, that can have no component along the direction of propagation of the EM wave. जबकि second term जो है, it is more interesting term by the way, and using the expression for E and A we can get a simple result, जो कि इन दोनों को E और A की एक्सप्रेशन जो पहले हम निकाल चुके हैं उसको सब्स्टिट्यूट करने पर निकलेगा. सो the orbital part, which is not so important, which is not so interesting, rather, so the orbital part can be shown to have no component, shown to have no component along the along the propagation of the EM field, of the EM waves. The second term, however, is interesting. In a sense, कब interesting? If we express them, if they are expressed in terms of E and A expressions. Uh, so a simple result for intrinsic angular momentum of the photon is obtained. कैसे substitute कर दें? So we have J, which is equals to 1 upon 4 pi C integral d3r, and what we are integrating E cross A, because the other term is the orbital part. And so this is equals to 1 upon 4 pi C integral d3r, and then we have iota. So this is d3r, and then summation over k comma lambda, summation over k prime lambda prime, and then we have 2 pi h c factor coming from E, capital E, and epsilon k lambda factor also crossed with ek prime lambda prime coming from A, the vector potential, yeah. And then we have those factors. So those factors are A k lambda e to the power iota k dot r minus k ct minus a k lambda dagger e to the power minus iota k prime dot r minus k prime ct. No, sorry, not k prime, not k prime, because we are writing for e. So this is not k prime. So we have k dot r minus kct. This is bracket close. Now both every k is primed times a k prime lambda prime times e to the power iota k dot r with a prime minus k prime ct plus a k prime r, sorry, lambda prime dagger e to the power minus iota k prime dot r minus k prime ct and bracket close. Yeah. So we have now we simplify again using solving the integral for k and k for primed and unprimed integrals. And so what we have is now j is equals to iota over 2 after simplification times h bar summation over k lambda lambda prime. So we have k lambda cross epsilon k lambda prime times the remaining factor ak lambda ak lambda prime dagger minus a k lambda dagger and a k lambda prime. Yeah. So the only non-zero term here are for lambda is not equals to lambda prime. Yeah. So if lambda is equals to lambda prime, then we have the terms equals to zero. Yeah. Because these two terms are separated by a minus sign. Yeah. And so the only terms which are non-zero would be the ones where lambda is not equals to lambda prime. And then ak lambda and ak lambda prime dagger, they would commute. Yeah. So uh, when summed over both lambda and lambda prime, we would get, in fact, two polarization vector which are crossed with each other, and that would represent the direction of the propagation of the field. Yeah. And so the the only non-zero terms here are when lambda is not equals to lambda prime. Yeah. And then, so then ak lambda vector and ak lambda prime dagger commute. Yeah. यानी दूसरे लफ्जों में जीरो हो जाएगा. So when we sum over, when summed over both lambda and lambda prime, what we get uh, we get by using an identity. कौन सी आइडेंटिटी? दैट इज अगर मेरे पास ई के लैम्डा अगर 1 हो क्रॉस्ड विद ई के लैम्डा अगर 2 हो, तो इसके ये किसके बराबर होगा? दैट वुड रिप्रेजेंट the propagation direction. That is the direction, because we have a cross product, and the cross product result would be something which is perpendicular to both of them. Yeah. And that is in fact your k vector. That is the propagation of the wave. And so agar solve karen, so this j vector would be equals to sum over k iota h bar k, which represents the direction of propagation of the wave, times ak1 ak2 dagger minus ak1 dagger or ak2 without dagger. Yeah. So eh, basically it is not exactly a very nice form with because the sum is obviously a number operator on the right hand side. Yeah. And so but if even though it's not very clear, or it is not so nice because the sum is over number operator on the right side, but it does suggest that the basic unit of angular momentum is h bar, जो कि हमें नजर आ रहा है right hand side पर h bar, um, along or basically opposite to the direction of propagation of the light. And so to see it more clearly, we consider another notation that is a notation which is not linear polarization, but in fact an elliptical polarization notation, or a circular polarization, rather circular polarization notation. And if we then represent that notation, then we would have a much more clear picture, suggesting that though on the right hand side there is h bar, but that h bar, although it is representing the angular momentum, but if we change the representation from linear polarization to circular polarization, then it would be more obvious that this would represent an angular momentum, and that would satisfy that there is an intrinsic angular momentum of the photon in some free field theory. Yeah. So we could write it all this. It is, though not exactly clear, in a nice clear form uh, with some some uh, sum over the number operator on right hand side. But what is suggestive from this, it does suggest that the basic unit of J comes from the h bar of the angular momentum J is h bar along or opposite to the direction of propagation of field, to the direction of propagation of light. of of light. आप इसको सोच सकते हैं, you can think about the right hand rule, or if you screw some screw in the inward direction, then that would represent your fingers would be pointing in one direction. If you unscrew it, then your fingers would be representing in the other direction. So यहाँ पर हम बात कर रहे हैं जो कि the basic unit of angular momentum is h bar, and this basic unit of angular momentum is h bar. It is either along or opposite to the direction of propagation of the light. And to see it more clearly, हम क्या करते हैं? We consider the changing the notation of the linear polarization. So uh, to to see that more clearly, consider changing the notation of linear polarization, which which is what a ak lambda dagger generates to something involving circular polarization. Circular polarization. Yeah. So uh, you can sort of obtain circular polarization, and that circular polarization is represented by plus and minus symbols, and that is a linear combination of the two basically creation operator along vertical axis and along the horizontal axis. So how do we obtain it? So therefore the circular polarizations can be obtained using linear combination of linear uh, creation operators. And what are those? कैसे करते हैं? So हम उसको represent करते हैं a k plus dagger. So a dagger represent, that is, you create a photon, and now you are saying you create a photon having a momentum k, but has a polarization which is denoted by plus, that is uh, positive circularly polarized light, yeah, corresponding to positive circularly polarized light. And similarly, अगर a k minus dagger होता, that would correspond to the creation of a photon, then minus sign would be representing the negatively polarized circular light. Yeah, and that is equals to 1 upon under root 2, which is the normalization factor with a minus sign here. 1 upon under root 2, because we have two components in the linear combination. One is vertically upward, and the other one is one is vertical polarization, and the other one is horizontal polarization. And the linear sum of these vertical and horizontal polarization would result in a circular polarization. And that is, in fact, AK1 dagger plus iota AK2 dagger. Yeah, so this is AK plus, and then so this is, let it box it. And similarly, AK minus dagger equals to 1 upon under root 2, and then we have AK1 dagger minus iota AK2 डैगर. सो 1 and 2 आपको मालूम है यहाँ दोनों में. सो इसको भी बॉक्स कर दें. यहाँ पर दोनों के अंदर लैम्डा जो है वो किसके बराबर है? 1, 2. या सो 1, लेट से 1 को हम कह दें वर्टिकल पोलराइजेशन, और 2 को हम कह दें हॉरिजॉन्टल पोलराइजेशन. सो वर्टिकल पोलराइजेशन एंड हॉरिजॉन्टल पोलराइजेशन, और वाइस वर्सा, कुछ भी ले सकते हैं, लेकिन लीनियर कॉम्बिनेशन होना चाहिए किसका? वर्टिकल एंड हॉरिजॉन्टल पोलराइजेशन का. एंड दैट लीनियर कॉम्बिनेशन वुड रिजल्ट इन सर्कुलर पोलराइजेशन. देन दिस प्लस एंड माइनस साइन वुड देन रिप्रेजेंट बिटवीन दोनों के दरमियान, दैट वुड रिप्रेजेंट द plus circularly polarized light and minus circularly polarized light. So this would be, this would correspond to correspond to plus uh, circularly polarized light, and this would correspond to minus circularly polarized light. Yeah. and so the corresponding हर्मिशन कॉन्जुगेट्स जो है उनके लिए भी हम ये निकाल सकते हैं, है ना। सो यहाँ पर हमने ए के प्लस के लिए और ए के माइनस के लिए निकाला है। सो हम ए के प्लस डैगर एंड ए के माइनस डैगर के लिए निकाला है, तो इनका इसका हर्मिशन कॉन्जुगेट जो होगा वो क्या होगा, ए के माइन प्लस एंड ए के माइनस एंड करस्पॉन्ड एंड also for corresponding uh, Hermitian conjugates. Hermitian conjugates क्या होंगे, AK1 and AK2 with commutation relation क्या हो जाएंगे, commutation relations क्या होगा, that would be AK plus A K plus dagger equals to AK minus AK minus comma AK minus dagger equals to 1, that is equals to 1, and बाकी क्या हो जाएंगे, जीरो हो जाएंगे, others are zero। कहाँ से, from the definition of commutators। Yeah, so this is basically in fact commutation relations for your in fact plus and minus, and you can have the inverse relationships as well. So the corresponding linear or inverse, which are basically linear inverse relations, और वो क्या हो जाएंगी, ए के वन डैगर वुड बी इक्वल्स टू, तो ऐड सब्ट्रैक्ट करते हैं तो हमारे पास दूसरी आ जाती है, माइनस ए के प्लस डैगर प्लस ए के माइनस माइनस डैगर, एंड इसी तरह से ए के टू डैगर, that would be equals to 1 upon, or that would corresponds to iota root 2, because we would have an iota in one of those terms। यानी सेकंड टाइम जब हम सब्ट्रैक्ट करेंगे तो जो सेकंड टर्म है उसके अंदर आयोटा मौजूद होगा, सो वो आयोटा बाहर आ जाएगा। सो दैट वुड बी ए के प्लस डैगर प्लस ए के माइनस dagger। So we have these two, and so those combinations which are appearing in the in